Welcome to Season 2, Episode 8, Part 2. Now, it wanted us to find the distance travelled in the interval of 0 to 5 seconds. Now, in the first part, we worked out that velocity was 0 at 2 points, when t is 0 and t is 3. And because it was a positive t squared, this is kind of like what the sketch will look like. Positive t squared means it's a happy face. If it was negative, it'd be a sad face. All right. Now, the issue with finding the distance between 0 and 5 is that some of it's below the x-axis and some of it's above the x-axis. The bit that's above the x-axis, which we already calculated, that would be regarded as a positive distance. But if we integrate between here and here, it would be regarded as a negative distance. If we just integrate the whole lot, we're going to get the positive distance subtract the negative distance, which is not what we want. We want the total distance travelled. So we need to make sure we integrate separately in the range of 0 to 3 and 3 to 5. If we only wanted the displacement, how far we've gone overall, then we wouldn't need to do this split. That's actually how we do Part C in a moment. But for now, we're looking at B. And so the total distance is going to be the integral between 0 and 3 of our function, added to the integral between 3 and 5 of our function. Now, I'm going to insert something a little weird in here that you may have seen before. Whatever area it gives me between 0 and 3, I want to force it to be positive. That just forces it to be positive. And we're going to add it to the area between 3 and 5, which is also forced to be positive no matter what comes out of it. All right, now we've already integrated this in the previous, in Part A. So look, t power goes up by 1, divide by the new power. 3t power goes up to squared, divide by the new power. Between 3 and 0, and we're adding that onto exactly the same. 3 take 3t squared over 2, except between 5 and 3. We actually evaluated this part in the last question. We know that it comes out at 26 over 3. So I'm not going to show you all the working there. We're just going to grab that from the previous question. Here, though, we need to do our working. So we've got to substitute in 3 over 3, take 3 squared over 2, and we need to take away what we'd get if you put 0 into all of that, which I hope you can see would just be 0. So that's it, and I'll change that bit we've already evaluated to the 26 over 3. So here I can keep going. So 3 cubed is 27, divided by 3 is 9. 3 squared is 9, so I get 27 there over 2. Take away 0, doesn't matter. Now that's 13 and a half. I could write that as 18 over 2. So, well look, I'll show you the full working. 9 is the same as 18 divided by 2 over 27 over 2 plus 26 on 3, giving us negative 9 on 2 sitting in there. But this is as I envisioned would happen earlier. When we found the area in here, because it's below the axis, it's given it as a negative. But we want it as positive. Distance is a positive measure. Doesn't matter whether you're going forwards or backwards, it's still distance travelled. So that forces it to be a positive 9 on 2, those absolute values, signs. And we get that. Do you want to do it by hand? You don't have to. You can put it in your calculator if you want, really. 27 on 6 plus 52 on 6 should give us, what's that, 79 over 6, which if you put it in your calculator is 13.16 recurring. Fraction will do though. Now remember the original question asked us the distance. We're working in, well, velocity was in meters per second, so the units in turn are going to be in meters. So you could write a sentence there. Therefore, the total distance travelled in the first 5 seconds is 79 on 6 meters. Yay!